Hello, class. Sorry I can't be with you again this Thursday, but I did want to take time to put together this video to help you get through the next section, which is about one sample t-test for the mean. And on your syllabus, this is I'm going to have to pull that syllabus up here towards the end and let you know what your assignment's going to be. But this is for hypothesis tests for a mean. And I've got three examples here that I want to work through, and I've attached this on the email. And so you should probably print this out and work along on that sheet as I go through these problems. This idea of hypothesis testing is going to give us a way to make some decisions based upon sampling from a population. Right, and so this first example is one that I've heard several times. I've been told that males who have been born and raised in Nebraska tend to be taller than the national average of 68 inches. To see if there is any merit to this claim, I took a simple random sample of 10 adult males who were born and raised in Nebraska and measured each of their heights. And the results are given here. Right, and so if you look at this sample, we've got one guy, the first guy there is 5'7", almost 5'8". The next guy is 5'5". And then you also notice that there's a couple guys in there that are 77.5 and 77.8 inches tall. Okay, that corresponds to about 6'5". And so what I want to know is, based upon this sample, is there any merit to that claim? All right, so I've taken these 10 numbers and found the mean. The mean was 70.91, and the standard deviation was 4.55. All right, so without really doing a whole lot of thinking, Part B on this question says, does there seem to be some merit to this claim based on the sample? And the answer is, obviously yes. If they say that the mean is 68 and we got a mean of 70.1 or 70.91, okay, that's almost 3 inches above the national average. Okay, and so the answer to Part B here, I think, would be, yeah, there seems to be some merit in this claim based upon this sample. Okay, now Part C is it possible that the sample we drew just happened to have several tall men in it? And the answer is yes. How likely is it, or is it likely that this is just kind of a weird sample that we got, this guy is 6'5", almost 6'6", this guy's 6'5" also, this guy's about 6'2", and this guy here is 6 foot. Is it possible that we just ended up happened to get a sample that had several tall guys in it? And the answer is yes, it could have just happened that way. All right, and really, when we do a hypothesis test, what we're really trying to do is answer this last question. How likely is it to obtain a sample mean, a sample whose mean is 70.91 inches or higher from a population that really only has a mean of 68 inches? All right, and that's the idea of taking a hypothesis test or performing a hypothesis test. Right, and you're going to find that we're going to do another kind of hypothesis test next week about proportions, and they're all going to follow kind of the same procedure. Right, and I think that if you follow this procedure, you'll end up being successful at doing these hypothesis tests. All right, so the first thing that we're going to do is we're going to write down some kind of a claim, and then what we're trying to do is kind of play the devil's advocate and try to disprove or to at least find some evidence against a claim. Right. So first thing that I want to do then is write down that claim. Right. And the claim here is that the average height for all adult males in the United States is 68 inches. Right. So this first step is called identifying the hypotheses. Right, we're going to identify the hypotheses as H sub 0, okay, known as the null hypothesis. The null hypothesis basically says whatever the claim is that somebody is making, we're going to assume that it's true. Right? And the claim there was that the mean, mu, is 68 inches. Okay, where this mean mu is the mean height of all adult males. Okay, and this isn't just adult males in Nebraska, this is adult males in the United States. All right, now we're going to also, every time we're going to end up with some kind of an alternative hypothesis. All right, what we're trying to show is, in the wording of the question, is there evidence to suggest this mean is higher than 68? All right, so our alternative hypothesis is that the mean is greater than 68 inches. Okay, so the idea here is we're going to assume that this is true, that the mean height for all adult males in the United States is equal to 68. I got this messed up a little bit. The mean height of all adult males this should be in Nebraska. Okay, we're assuming that Nebraska is no different than the United States, and we're looking for evidence to suggest that the average height of adult males in Nebraska is greater than 68. Okay, so the next step after the hypotheses is to check conditions. Right, now the conditions here are the conditions that are going to allow me to say that the sampling distribution of the mean is approximately normal. Right, now the two conditions that we have here are population is normal, or n is bigger than or equal to 30. All right, now our sample size was only 10, so what we need to do is justify that the population of heights is approximately normal. All right, now if you go back to the question never really said anything about what the distribution of these heights is, and all we have to look at is this one sample. All right, and so what we're going to look at in that sample is there evidence to suggest that this sample might have come from a normal population? Okay, well, if the sample came from a normal distribution, we'd expect that the sample is also going to look fairly normal. All right, so we're going to look at a graph of this distribution, and this is of my sample, and this is just a box plot. All right, what I see in this box plot is that this distribution is slightly skewed to the right. Okay, this right whisker is a little bit longer than the left whisker, but what I don't see here is any strong skewness, and I don't see any outliers. All right, so what I'm going to do is assume that this distribution, because I don't see any outliers and I don't see any strong skewness in this sample, I'm going to assume that these came from a normal population. All right, so I'm going to assume that the population was normal because there were no outliers in the sample. Okay, now we only have to do this when n is less than 30. Okay, if n is bigger than 30, then all we have to do is say that the sample size was big enough. All right, so what this allows me to do then is basically invoke the central limit theorem. Okay, now the third step is really the mechanics or the mathematics part of this one. And what we're trying to do here is answer part D. How likely is it to obtain a sample whose mean is 70.91 inches or higher from a population whose mean is 68? Remember that we're assuming that the population mean is 68 inches. Okay, so let's go back to here and say, all right, now we're trying to find the probability of getting a sample mean that's bigger than 70.91. All right, so if I think about this sampling distribution of x bar, okay, it's going to end up looking something like this, and we're assuming that the mean is 68. Okay, we got a mean of 70.91. And the question is, what's the probability that we're going to get a sample mean this large or larger? All right, now the problem here is, again, I can't use the central limit theorem directly because I don't know what sigma is. The only thing I have is the standard deviation of the sample, and we found that our sample mean was 70.91, and we found that our standard deviation was 4.55. Okay, and again, this is a sample standard deviation. All right, so in order for me to answer this question, I'm going to have to use a t-distribution. Okay, and so to find the probability that x bar is bigger than 70.91, I'm going to have to look at calculating a t-statistic for this. Right, and the t-statistic is going to be found by taking x bar minus mu divided by S over the square root of n. And this is how I calculate my t statistic. Okay, this looks just like a z statistic, only in a z statistic we have sigma here instead of s. Alright, so I'm going to plug in my values. X bar was 70.91. The mean I'm assuming is 68. Standard deviation of the sample was 4.55. And my sample size was 10. Alright, so when I calculate this t statistic, I'm going to find that this is 2.022. Okay? Alright, now you can interpret this as being about 2 standard deviations above the mean. So when I calculate this probability, it's really the probability of getting a t statistic that is greater than 2.022. Alright, now the other thing that we need to look at on this one is what's my degree of freedom? The degree of freedom, again, is going to be n minus 1, and n minus 1 in this case is 10 minus 1 is 9. Alright, so we're looking at what's the probability of getting a t statistic that is bigger than 2.022. Okay, now there's two ways that we could do this. We could use the table, alright, but the table is going to be kind of restrictive because we're probably not going to be able to find a t statistic exactly 2.022 in the table. Right, but what I can do is I can look at a t distribution with 9 degrees of freedom, and it's going to look something like this. Let's call this T9. And what I want to know is what's the probability of being at 2.022 or higher. Okay, now if this was a normal distribution, we could just use normal CDF. All right, your calculator is really set up to do this as well. To calculate the probability of getting a t statistic that is 2.022 or higher with 9 degrees of freedom, okay, the command is tcdf, and then all we have to do is put in the lower value and the upper value and the degree of freedom. Alright, so on this one I'm going to put in tcdf. The lower value is essentially negative infinity. I can just put in like negative 1,000. The upper value is 2.022, and the degree of freedom on this is 9. Okay, so on the calculator, this is under second vars. Okay, if you go down to tcdf, and we put in negative 1,000, and 2.022 and 9 degrees of freedom, it tells me, oops, I didn't do that right, sorry. We're looking for the probability of being at 2.022 or higher, so this is going to be tcdf. The lower value on this one is 2.022. The upper value is essentially infinity and then 9 degrees of freedom. Okay, my bad. Alright, so second vars tcdf 2.022 to a big number with 9 degrees of freedom. Alright, we find that that probability is 0.037. Okay, now this is where we really have to kind of make a decision. Okay, this is the fourth step. The third step is all the mechanics. This is all about using the t distribution and also using the central limit theorem to come up with this probability. Right now, it's important that we were able to understand what this probability is. This probability is really answering the question that was asked back here on part D. How likely is it to obtain a sample whose mean is 70.91 inches or higher from a population whose mean is 68 inches? Okay, so this 3.7% is the probability that we're going to get a sample mean that is this high or higher if this is true, if the null hypothesis is true. All right, now what I would think is that most people would say that this is a very low probability. Something happens 3.7% of the time is an unlikely occurrence. All right, so one of two things happen. One is that we ended up with just a sample that had a lot of tall people in it, or the other explanation would be that maybe the mean really isn't 68 inches. Maybe our assumption was wrong, and maybe our alternative hypothesis is actually more the case. Right? And so if we interpret this as being a small probability, I'm going to say that the smaller this probability is, the more evidence there is against this null hypothesis and in favor of the alternative. Right? And so my conclusion is going to involve basically three things. The first thing is we're going to reject the null hypothesis. Okay? I'm saying that because this probability is so small, I'm going to say I don't think that this mean of 68 is actually a true statement. I think that this is probably more the case, that the mean is bigger than 68. Okay? And I'm going to say that because, and this is actually just called a p-value of a hypothesis test. Okay, I'm going to reject the null hypothesis because the p-value 0.037 is low. And I'm going to say there is sufficient evidence to suggest that the alternative hypothesis is true. The mean height for all Nebraskans, or male Nebraskans, okay, let's say adult male Nebraskans, the mean height for all adult males in Nebraska is greater than 68 inches. Okay, so this is kind of the flavor of a hypothesis test. Okay, the first step is write down your hypotheses. Okay, and I'll tell you that your book talks about hypotheses that can be written a couple different ways. I think we always want to make this an equation. In other words, we're going to make some claim about that the mean is some particular number. Okay, the alternative hypothesis is, depending upon the question, it could be greater than, could be less than, like in my next example, or it could just be not equal to. Okay, my second step is to check the conditions. We either have to have some evidence that the population that these came from was normal, or we need to know that the sample size was big enough. The mechanics here is really calculating a probability that we're going to get a mean that is as extreme as the one we got, assuming that the null hypothesis is true. And in order to do that, we're going to end up having to use the t-distribution. Okay, once we use the t-distribution, we're going to come up with a probability. Okay, this is a conditional probability. This is the probability of getting a sample mean this big or bigger, and the condition is that the null hypothesis is true. If this number is small, we're going to say we have evidence against this claim. Okay, it's unlikely to get a sample mean this big from a population whose mean is really only 68. Okay, and then in our conclusion, we're going to either reject or fail to reject the null hypothesis. We're going to give a reason. The reason is because the p-value is big or small. And then we're going to just say that in context. Okay? All right, so this is really pulling a lot of things together that we've done throughout the course, and especially in the last couple of weeks, in terms of probability. All right, but this is how much is going to be involved in doing a hypothesis test, and there's quite a bit of stuff there in that third step. But I think you're going to find that the more of these you do, the easier they are to kind of come up with answers. All right, but this is a complete answer here, and this is what I would expect for you to write out on a hypothesis test. All right, again, you get to use your notes for the next couple of tests, so you might want to just put down an example of something like this on your note sheet so that you can refer back to it. Okay, so let's move on to the next question. The next question is another hypothesis test. Okay, and this one says a statistics student believes that the mean amount of money spent on a trip to the grocery store is $75. Another student believes that the mean amount is less than $75, and he challenges the claim by sampling 32 customers at a local grocery store and asks them, how much money did you spend? And the results are summarized in the table below. All right, so he sampled 32 people. He found that the mean amount of money that they spent on groceries was $69.25 or $69.25, and the standard deviation of those 32 people was 25.2. Right, and then again, the question here is, does this sample provide sufficient evidence, right? And we're going to talk about this here in a minute at the 0.05 level to suggest that on average people spend less than $75 per trip to the grocery store. Okay, so on this one, again, we're going to set up a null hypothesis. The null hypothesis is that the first student's claim is true, that mu is 75, right? And here we're saying mu is the mean amount of money spent per trip to the grocery store. Okay. The alternative, all right, now we got to read into the question on this one. The second student was suggesting that it's actually less than that. All right, so our alternative hypothesis is that mu is less than $75. Okay, so that's step number one. Step number two is to check conditions. Okay, this is easy because n was 32. Okay, n is greater than 30. All right, so if n is greater than 30, we can assume that the sampling distribution is approximately normal. All right, so we're off the hook on that one pretty easily. Okay, then the third step is we want to find what is the probability that in our sampling distribution of x bar, we're assuming that this is 75, and we came up with a sample mean that was 69.25. Okay, and what we're trying to do here is find out what's the probability that we're going to get a sample mean that is less than 69.25 from a sample from this grocery store. Sample of 40 people. All right, now, so we're trying to find out what's the probability being over here. All right, so we're going to end up having to, again, calculate a t-statistic. That t-statistic is going to be found by taking 69.25, subtracting 75, divide that by the standard deviation, and the standard deviation on this one was 25.2, and divide that by the square root of the sample size, which was 40. Right, and we're going to find that the t-statistic here ends up being equal to negative 1.29. Okay, so again, you can think about this as being 1.29 standard deviations below the mean. All right, so to find this probability, all we have to do then is find the probability of getting a t-statistic that is less than negative 1.29. All right, and then we also need degrees of freedom on this one. We had a sample size 32. So we're going to end up with 31 degrees of freedom. Okay, so on our t-distribution, we're looking for what's the probability that we're going to get a t-statistic that is below negative 1.29. All right, so this is the t-distribution with 31 degrees of freedom. Okay, so to do that, we do t-CDF. The lower value on this one is negative 1,000. The upper value is negative 1.29, oops, and the standard deviation, or I'm sorry, the degrees of freedom is 31. There should be a comma. Okay, so again on the calculator, second bars, t-CDF, we're going from negative 1,000 to negative 1.29. And we've got 31 degrees of freedom. Okay, we find that this p-value is 10.3%. Okay, so now this is, again, a probability. It's the probability that we're going to get a sample mean that is this low or lower if the mean is 75. Okay, this is going to happen about one time out of 10. Right now, many people might say that this is a low probability. Okay, and I would not argue with somebody that said that 10% of the time you're going to get a success is a low probability. But it's not really that unusual. 1 out of 10 times something happens. Okay, I'm not really surprised that it did happen. Okay, so what we need to do here is decide when are we going to call a p-value low and when are we going to call a p-value not so low. All right, and the idea here is this idea of a alpha level. All right, so this says, does the sample provide sufficient evidence at the alpha equals 0.05 level? All right, all this means is that we're saying that anything that's below 5% is small, anything above 5% is large. Okay, it's just we're drawing a line in the sand and saying we're all going to agree that anything less than 5% is low, anything greater than 5% is high. All right, so in our case, we've got a p-value of 10.3%. Okay, according to that line in the sand, this is a high probability. All right, so my conclusion is, okay, it's not to accept the null hypothesis, but it's to fail to reject it. All right, we failed to reject the null hypothesis. Okay, we're saying we don't have enough evidence against it. Okay, and again, we want to say a reason why. And my reason is because the p-value is 0.103, and that's greater than 0.05. Okay, it's bigger than the alpha level. All right, and then the context of this is we do not have sufficient evidence to suggest that mu is less than $75. Okay, so the guy who claimed $75 at the beginning, we're not saying that he's exactly right, we're just saying we don't have enough evidence to suggest that he is wrong. Okay? Alright, so this is another hypothesis test. It should look very similar to the first one. The only difference is here we've got a less than sign, and with a less than sign, all we're going to do different is we're going to end up calculating a left tail probability instead of a right tail probability. Otherwise, the 4 steps are very, very similar. Okay, so let's move on to the last one, is the hypothesis test with the airline tickets. All right, and let's see what the wording is on this one. All right, a popular website advertises that the mean price of a domestic airline ticket is $570. Okay, to test that claim, a statistics students take a simple random sample of 40 prices of airline tickets and finds the mean to be $595 with a standard deviation of 125. Does this sample provide sufficient evidence at the 0.05 level? Okay, so again, we're going to be calling that anything less than 0.05 is small. Anything bigger than 0.05 is large, to suggest that the mean ticket price is not $570. Alright, so this one has a little bit different wording, and that different wording is right here at the very end. The price is not $570. Alright, so when we set up our hypotheses, again, we're going to assume that the claim that was given is true. Okay, that the mean price is $570. Okay, and over here I'm going to say mu equals the mean price for all domestic flights. Okay, and then we have an alternative hypothesis, and that alternative is not equal to 570. Okay? Second step. Okay, the second step, we got to check the normality. Okay, the normality here is, well, n was equal to 40, I believe it was. Yeah, n was equal to 40. And with n equals 40, that's bigger than 30. Okay, so we're off the hook on that one. Okay, I'm just looking back on that previous problem. N was actually 32 in that last problem, and I think I wrote down 40, but my calculations ended up coming out to be with if I put 32 in that denominator instead. So go back and check that. Let's see. Let me show you where the error is. Okay, my error was here. This was just a typo. That should say square root of 32. You still get negative 1.29. Okay, even if you put in, this was just a misprint. Okay, but here, n was equal to 32. That should say 32 here. N is still bigger than 30. Okay, so our conditions are met. Next thing we want to do is we want to calculate a probability. All right, and this one is just a little bit different than the other two. All right, so we're assuming that this is 570. Right, and this is the sampling distribution of the mean. Okay, our sample was 595. Okay, so we do want to calculate this probability, but we're looking at the probability that mu is not 570, or we're looking at some evidence against 570. So we also need to kind of take a look at what would happen over in this other tail. All right, so let's kind of hold off on that for a second and say, is this 595 a lot bigger than 570? Enough to suggest that this is a true statement up here. All right, so to calculate that, we're going to look at the probability that x bar is greater than 595. Okay, and in order to do that, we're going to have to use a t-distribution. So we're going to get a t-statistic for this 595. So 595 minus 570 divided by the standard deviation. Standard deviation in this problem was given as 1.2 or 125, and the sample size on this one was 40. All right, so we're going to get a t-statistic on this one that's equal to 1.26. Okay, so this is the same as the probability of getting a t-statistic that is greater than 1.26. All right, and the degree of freedom on this one is 1 less than 40, or 39 degrees of freedom. Okay, so to calculate this probability, again, we're going to do a TCDF. So second bars, TCDF. Our lower bound on this one is 1.26. And our upper bound is infinity, and we got 39 degrees of freedom. Okay, and when I calculate, I get that to be about 10.8%. Okay, now that's going to give me the probability of getting a sample mean of 595 or more, but really we want to look at not just how far this is above the mean, but how far it is away from the mean. All right, and so we're looking at what is the probability of getting something that is this extreme. All right, and so what we need to do also is notice that this is 25 units. So if we go in this direction 25 units, we're going to be down here at 545. Okay, and if we want to calculate that probability, the probability of being at that value, okay, we're going to find that that red area is exactly the same as this black area. All right, and so the probability that we're really calculating here is the probability that we get a sample mean that is bigger than 595 or less than 545. All right, and then essentially all we do is we just end up taking twice this probability, and we get twice 0.108, which is going to give me 0.216. All right, so for a hypothesis test that is two-tailed or a not equal to up here, all we're going to do is calculate one of these probabilities and then just double it. Okay? All right, and then the last step is we need to make a decision. Okay, again, this is a high probability. Something that happens 21.6% of the time is not very unusual. All right, the wording on this one was at the 0.05 level again. So Here we're going to fail to reject the null hypothesis, and the reason is the p-value is equal to 0.216, right? And it's important that I say that that's greater than 0.05. Okay, it's not just that it's equal to 0.216, it's that that number is bigger than 0.05. So we do not have sufficient evidence to suggest that mu is not 570. All right, it seems like kind of a double negative there, but it's really kind of like in a court of law. We are kind of the prosecuting lawyers, and we don't really say in a court of law that somebody is guilty or innocent. We say that they are either found not guilty. Not guilty is kind of the same thing as saying fail to reject the null hypothesis. Okay, we're not saying that the null hypothesis is true, we're just saying that we don't have enough evidence against it. Okay, so we fail to reject the null hypothesis because the p-value is large. We do not have sufficient evidence to suggest that the mean is something other than 570. Okay, in the big picture here, this number was not far enough away from this number. All right, that's really what the big picture is. And this probability measures how likely that is to happen. How likely is it for us to get a sample mean that is $25 away from the expected value with a sample of 40 airline tickets? Okay, so the probability is fairly high, so we fail to reject the null hypothesis. Okay, hopefully that is going to give you enough to work through the homework problems. And speaking of the homework problems, let me make sure that I show you which problems I want you to do. So let me call up the syllabus. And on the syllabus, problems I want you to do are mean tests, section 8.4. So you should be doing these problems here from section 8.4. Okay, page 413, and those problems. Okay, a lot of those problems are just very similar to the problems that I just went through with you. Okay, so for Tuesday you should have finished up section 7.3. Okay, for next week you should be working on section 8.4, which is doing hypothesis tests for a mean. Okay, and then next week we are going to meet, and next week I want to pick up estimating a proportion, and then also doing hypothesis tests on the proportion. And that's section 8.3. So we're going to be doing 7.2 and 8.3 next week. All right, and then we've also got an exam coming up, and we've also got a final coming up. All right, so that exam number 3, I'm going to have that scheduled for next Thursday. Okay, next Thursday will be the 4th, I believe. And then the next week we will have a final review, and then on the Thursday of that next week will be our final exam. Okay, so we will meet on Tuesday. We'll do a little bit of review stuff, and we'll take our exam next week, and then the week after that will be final review and final exam. Okay, so like I said, I'm sorry that I wasn't able to be with you this week, but if you do have any questions, I am available on my email, so make sure that you ask questions, but you will have an opportunity to ask questions next week when we meet. Okay, thanks a lot, and have a good weekend, and I will see you later. All right, bye.